fundamental theorem of algebra. You don't hear this theorem a lot, but what is worth mentioning is the factoring technique, because if you forget to study this and your instructor put that on a test, you might lose a full grade, because the factoring technique is so interesting. But before we go into the factoring technique, let's take a look at the theorem. So the theorem says every polynomial with complex coefficient has at least one complex zero. So complex zero has three different names. Some textbooks use the word zero, sometimes they use the word root, and sometimes they use the word solution. So complex zero, complex root, complex solution, depending on your textbook. So let's take a quick review of what complex number is. So 5 is a real number, right? So 5, 6, 7, 8, 9, 10. So these are real numbers, but 5 is also a complex number. So if you want to put a 5 in a complex number, you write 5 plus 0i. What is I? I is the square root of -1. So the square root of negative is undefined, because the square root of negative is not a real number. It is a complex number, which is I. So 5 plus 0i. Did I change the value of 5? No, because I know is square root of -1, but when you multiply 0, it is 0. So 5 plus 0i is a complex number, but 0 times I is gone. So 5 itself is a real number and a complex number if you decide to write the 5 like this. So overall, let's say we have a rectangle, and these rectangles represent all kinds of complex numbers. So inside the rectangle, you have all kinds of complex number. Complex number can be divided into two groups. The first group is a real number. The second group is imaginary, just like this. 5 plus 0i. 5 is real, and then I is imaginary. So I can give you another example, like how about 5 plus 3i? This is a complex number. You have real, which is 5, and then 3, and then you have imaginary, which is I. Of course, you can do a minus, like 5 minus 8i, or 10 minus 2i, 4 plus 13i, something like this. All right, so let's get to the next point. The next point is factor completely. So factor completely means I want to find out all the factors and find the zero. Find the zero means you are looking for when y is equals to 0. So when y is equals to 0, what is x equals to? All right. So this is a third degree polynomial, because the highest degree is 3. So this is a third degree polynomial. All right, so third degree polynomial, I said every polynomial, right? So that means include the third degree polynomial. So since this is a third degree polynomial, this polynomial has at least one complex zero. At least one means the minimum is 1. It can be 2, 3, 4, 5, 6, 7, 8, 9, 10. The minimum is 1. Let's say you have at least one car. So the minimum is 1. You can have 1,000 or 6,000 cars. All right. So first step, let's do factor by groups. So we studied this many times. So basically we've grouped the first two factors. So x3 minus 3x squared, and then plus 4x minus 12. And then we set that equals to 0, because we are looking for zeros, right? So you group the first two factors. So do I need to change the sign? The answer is no. But if this is a minus 4x, and then you group the last two terms like that, you have to change this to a plus if this is a minus. If this is a minus 4x. All right? So we factor as much as we can. So x squared, greatest common factor. So x minus 3. And then this one, we take a 4 out. And then you have x minus 3. You have that equals to 0. And then do you see that? You have x plus x minus 3, right? So we take x minus 3 out, and then you have x squared plus 4 equals to 0, and then you say, all right, so x equals to 3, but x squared minus plus 4 equals to 0 has no solution, because it doesn't matter what number you have, you square that number becomes positive, you add 4 to it, you will never get a 0, even though x equals to 0. All right, so that is what we have to discuss, because when you set that equals to 0, you get complex zeros or complex solutions. All right. Okay, so before we get into that, we want to do a quick review. The quick review is a squared plus b squared cannot be factored. Right? A squared plus b squared cannot be factored. So people will say, well, this cannot be factored anymore. It is what it is. But there is a secret that we have to discuss in this video, and that is the biggest purpose. Okay, so let's do this real quick. So let's say we're using zero product property. We have x squared plus 4 equals to 0. Subtract 4 on both sides. So you have a minus 4. And then we take the square root on both sides. Since this is a second power, you have to address the plus or minus. Square root of negative 4 using complex number. So this is a plus or minus negative 1 times 4, right? The square root of 4 is equals to 2. And then the square root of negative 1 is I. So this is a complex number. But how about the factor? I need you to show me the factor. Okay, factor. So here is the technique. Now watch, that is the whole purpose of making this video. You have x minus 3. There is a way to factor x squared plus 4. I always say this cannot be factored because we don't need to use complex number. But if the problem asks you to factor completely, here is the secret. Watch. So you have, watch me, x plus square root of negative 4. And then x minus the square root of negative 4. That is equals to 0. Okay, this is the secret. So that is the whole purpose of this video. I want to show you how to factor a squared plus b squared. All right. How do you know this is correct? So this one, when you multiply, x times x is x squared, right? And then you have a past a negative, because this is a minus, x times square root of negative 4. But when you add this back, so you have a minus and then you have a plus. So the minus and the plus cancels each other. And then you have this. You have let's use a different color. So you have a plus square root of negative 4, and then you multiply a minus square root of negative 4. Plus and minus, that gives you a negative 1. And then square root times square root, you remove the square root, and then that is equals to 4. So basically, you will just get this 4 back when you multiply. And then the plus and the minus will just get rid of each other, just like a plus b times a minus b. And then back to our problem. So we have x minus 3 equals to 0, x plus square root of negative 4 equals to 0, x minus square root of negative 4 equals to 0, and then this is x equals to 3, and then this is x equals to the square root of negative 4, x equals to, plus, you subtract, right? This is a minus, this is a plus, and then what is this? The square root of 4 is 2, so you have the minus, square root of 4 is 2, and then the square root of negative is I. And then this is x equals to, square root of negative is I, square root of 4 is 2. So this one, and that one, where is the complex zero? So this is the complex zeros. And then you have 2 complex 0, and then this one is a real solutions or real zeros. All right, so before we end this video, I want you to practice one more. So let's say we have, actually this is not a practice. So let's say you have a plus. What happens when you have a plus? This is easy, right? So when you have a plus, you just change that to x plus 3 and then x minus 3. And then when you set that equals to 0, you have x equals to 3 and negative 3. So they are real zeros. But when you have changed the x squared plus 9 to the x squared minus 9 to a plus, so when you change this to x squared plus 9, and then you have to do this, you have to do x plus the square root of negative 9, and then x minus the square root of negative 9. Okay, so when you set that equals to 0, remember x times x, you have the x squared, you have a plus, you have a minus, they get rid of each other, and then when you multiply, you have a minus 1, but square root of negative 9 times square root of negative 9, you remove the square root there, is another negative, right? So negative 1 times negative gives you the positive 9 back. So this is a x plus 3 square root of negative 1 is I, and then x minus square root of 9 is 3, square root of negative 1 is I equals to 0. So you have x equals to negative 3I and then positive 3I. So these are the complex zeros. All right. So hopefully this technique stays in your mind. So when you see this on a test, factor completely means you need to show the factor form. What factor form? This one. You have to factor completely. And then here, you have to factor completely. Factor all the way to the end. All right? So that's it for this video. If you like the way I teach math, give this video a thumbs up. Subscribe to my channel for more contents like this. As always, I will meet you all in the next one.